Okay, to graph this rational function right here, we need 4 pieces of information. We need the end behavior, okay, what happens as x goes to infinity and x goes to negative infinity. We need vertical asymptotes, we need x-intercepts, and we need y-intercepts. So let's start with the end behavior. To get the end behavior, we have to go to the numerator and figure out the leading term there. So we're going to take the 3 times the x times that x, which is 3x squared. And we have to figure out the leading term in the denominator as well. So it's that x times that x, or x squared. So then we have 3x squared divided by x squared. Since the degree of the top is the same as the degree of the bottom, the horizontal asymptote is the ratio of the leading coefficients, or 3 divided by 1. Okay, to get the vertical asymptotes, we notice that negative 4 makes this factor 0. Since the x plus 4 does not cancel from the numerator, we know that negative 4 is a vertical asymptote, or x equals negative 4. Also, this x minus 2 does not cancel, so x equals 2 is also a vertical asymptote. Okay, the x-intercepts are what make the function 0. Okay, the only way that a fraction can be 0 is if the top is 0. So the top is 0 if here we see that x equals 1, or here we see that x equals negative 3. So 1 and negative 3 are the two x-intercepts. Finally, we need the y-intercepts. Okay, the y-intercept we get by substituting 0 in for these x's. So here we have 3 times negative 1 times 3, which is negative 9, divided by 4 times negative 2, which is negative 8. Okay, so now we have all the information we need. We know that y equals 3 is a horizontal asymptote, x equals negative 4 and x equals 2 are vertical asymptotes, x equals 1 and negative 3 are x-intercepts, and our y-intercept is 9/8. So I'm going to graph all these pieces of information first. Okay, so here we have our horizontal asymptote, our two vertical asymptotes, x-intercept, y-intercept, x-intercept. So let's get from this x-intercept here to this first vertical asymptote. Because this is a vertical asymptote, I know the options are that it goes up there or down there. Okay, to figure that out, which one it is, I'm going to say, all right, I need to go from that y-intercept to that x-intercept. So I want to find the multiplicity of that x-intercept. If it's an even multiplicity, I know the graph will bounce. If it's an odd multiplicity, I know that the graph is going to pierce the x-axis there. So that is a 0, which is x is equal to 1. So I go to this factor x minus 1, and I see the multiplicity of it is 1. So I know that the graph of the function going from this y-intercept to here is going to pierce the x-axis there. So the only way that I can get to this vertical asymptote here is to go downward, because if I were to go upward, then I would cross the x-axis again. But I know that I've already plotted all of my x-intercepts, so I can't cross the x-axis again. So this has to go down on this side of the vertical asymptote. Okay, so now since I went down toward negative infinity on this side of the vertical asymptote, I'm going to look at the fact that this vertical asymptote is x equals 2. So that's coming from this factor of x minus 2 in the denominator. Since the power of that is 1, I know that this vertical asymptote has odd multiplicity. So that means that since it went down on the left-hand side, it has to go up on the right-hand side. Then to get the y-intercept, to get the y-asymptote of y equals 3, we know it's just going to go like this. Okay, now I want to move from this y-intercept to this x-intercept. So I see that this x-intercept, x equals -3, has multiplicity 1. So I know that the graph has to pierce the x-axis there. Since it has to pierce the x-axis, then the graph must continue downward. The only way for it to go upward to this vertical asymptote is to cross the x-axis again, but we know there are no more x-intercepts. Okay, so this graph has to go downward. Okay, now we need to pick up on the other side of the vertical asymptote. So this vertical asymptote is x equals -4. This factor of x plus 4 in the denominator has a power of 1 again. That means that the vertical asymptote has a multiplicity of 1, which is an odd multiplicity, so since the graph went down towards -infinity on this side, it must have the opposite behavior on the other side, so it must go up towards infinity. Okay, so since it's going up towards infinity there, to finish it off, we know again we have the horizontal asymptote of y equals 3, so it's going to fall and approach y equals 3. So this green graph here is the graph of the function.